Students, in this video we are going to discuss about the unit step response of second order underdamped system. So we start with the transfer function. We are very familiar. The second order system transfer function is C of s divided by R of s is given as omega n square divided by s square plus 2 zeta omega n s plus omega n square. So if you see, this zeta is we have seen in the last video. Zeta is the damping ratio. Omega n is the natural frequency of oscillation. Natural frequency of oscillation. Okay, since we are dealing with the underdamped system, for the underdamped system, zeta is going to be between 0 and 1. The zeta range is between 0 and 1, and it's a unit step response. So the input is unit step. Input is equal to unit step. Input I mean here is the R of t. R of t, the input is unit step. So if you take Laplace transform of the input, which is R of s, taking Laplace transform, we get R of s. For the unit step, the Laplace transform is 1 divided by s. So what is the output? C of s is equal to, bring R of s to the right hand side, R of s multiplied with omega n square divided by s square plus 2 zeta omega n s plus omega n square. Okay, now you plug the value of R of s, it would be 1 by s. So it is omega n square divided by s times s square plus 2 zeta omega n s plus omega n square. Okay, so we very well know the denominator, this is going to be a complex, right? This term, this term, if you solve this term, this would be a complex one. Underdamped system, this would be complex, right? So if you take partial fraction, you can write this as, that is omega n square divided by s times s square 2 zeta omega n s plus omega n square is equal to, taking partial fraction. Taking partial fraction, it is one of the term is real, that is a by s. Other two roots is complex, so it would be in the numerator I can put bs plus c divided by s square plus 2 zeta omega n s plus omega n square. Okay, now solve for ABC. Solve for ABC, so it would be a times s square plus 2 zeta omega n s plus omega n square plus bs plus c times s whole divided by s times s square plus 2 zeta omega n s plus omega n square is equal to omega n square divided by s times s square plus 2 zeta omega n s plus omega n square. Okay, so what will happen? We can cancel the denominator on both the sides. These two sides will be cancelled, so we will be getting omega n square is equal to a times s square plus 2 zeta omega n s plus omega n square plus multiply s inside, it would be bs square plus cs. Okay, now split the into coefficients of s square s term separately, bring multiply inside a 2 zeta omega n a s plus omega n square a plus bs square plus cs omega n square. So if you see here, we have the s square term, so taking s square up outside, it would be a plus b s square plus, what are the other terms we have? We have s term, so this is one s term, this is another s term. Taking s outside, we should be getting 2 zeta omega n a plus c times s. Then we, of course, we have a constant term which is a omega n square equal to, okay, right. Now equating coefficients on both the sides, equating coefficients on both sides, okay. What about the constant here? This is a constant term, this is a constant term, right? So it would be a omega n square equal to omega n square. So a is equal to omega n square divided by omega n square equal to 1. So a equal to 1. You got it. Then what about other coefficients? We don't have the s square coefficient on the left hand side, so on equating, that is equal to 0. A plus b is equal to 0. Since a is 1, b is equal to minus a, so b is equal to minus 1, right? Now equating the coefficient of c, a coefficient of s, right? What is the coefficient of s? This is the coefficient of s, right? So 2 zeta omega n a plus c equal to, the left side we don't have any coefficient of s, so it's 0. Okay, now plug the value of a, which is 1. So c is equal to minus 2 zeta omega n a. Since a is 1, so it is minus 2 zeta omega n. This is the c value. Okay, so you got a, b and c. Now you can put it here in this equation. You can put it here, a, b, c values. Okay, so your c of s is going to be a by s. So a is 1, so 1 divided by s plus minus bs plus c. So minus s minus 2, in place of c I am substituting minus 2 zeta omega n divided by s square plus 2 zeta omega n s plus omega n square. Take the minus outside the second term, so it will be 1 by s minus s plus 2 zeta omega n whole divided by s square plus 2 zeta omega n s plus omega n square. So this is your c of s. We need to take inverse Laplace transform, we will get c of t, but it's not straightforward because for 1 by s it's cc, 1 by s it is u of t, but for this term we have to work. Okay, so you should be knowing these two inverse Laplace transform relationship, okay, which is omega by Laplace transform, omega by s plus a square plus omega square. The inverse Laplace transform would be e power minus at sin omega t. And there is another expression, s by s plus a square plus omega square. For this, the inverse Laplace transform is e power minus at cos omega t. Okay, so if you know these things, then it will be easier for us to solve the second equation. Okay, now if you look at the second equation, we have to bring into one of this format, either this or this, so that we can write it in terms of sine and cos. Okay, so further what we are going to do is we write it again, c of s equal to 1 by s minus s plus 2 zeta omega n divided by s square plus 2 zeta omega n s plus omega n square. Okay, so we want to write this in terms of a plus b format. Okay, so what I am going to do is, you see here, let me take, this is a, this is a, right, and okay, so this is a square, this is a, okay, this is 2, and this would be your b, because we very well know a plus b whole square is equal to a square plus 2ab plus b square. Okay, so we want to write the denominator in terms of this. Okay, so what is missing here? We have a square, 2ab, b square is missing. That means zeta omega n square is missing in the denominator. So we can write this as 1 by s minus s plus 2 zeta omega n whole divided by s square plus 2 zeta omega n s. I am going to introduce b. What is b? That is b square. B square is 2 zeta omega n square. Okay, so it is plus 2 zeta omega n square. Again I am going to subtract. Okay, I am just adding and subtracting. And what is the last term, which is omega n square? Right? Is this okay? Now one by s minus s plus 2 zeta omega n. Now look at this term. Can I write this as s plus zeta omega n whole square? S plus zeta omega n whole square. Then we have minus, sorry, I'm making a mistake here. It should not be 2. B is, what is b? B is zeta omega n, right? So it is b is zeta omega n. So b square is zeta omega n square. So you don't have 2 term here. Okay, right. So this term gets reduced to 2, s plus zeta omega n whole square. Then write the remaining terms, which is zeta omega n square plus omega n square. Okay, so you can write it as minus s plus 2 zeta omega n whole divided by s plus zeta omega n square, plus from these two terms, I can take omega n square outside. Okay, you can take omega n square outside. It would be minus zeta minus zeta square plus 1. Okay, what I am going to do is 1 by s minus s plus 2 zeta omega n divided by s plus zeta omega n square plus omega n square. Can I write this as 1 minus zeta square? Okay, the next step, just I am writing as s plus 2 zeta omega n divided by s plus zeta omega n square plus, I can write this as omega d square. Please note, omega d is the damped frequency of oscillation. The last video we have written omega d is nothing but omega n square root of 1 minus zeta square. So omega d square, right? Now this variable looks like this c of s is very, now you can compare with this. You can compare with this expression, these two. You can compare with these two, and we can see it is s plus a. Look at the denominator, it is s plus zeta omega n. In the numerator it is s plus 2 omega n. So further we have to manipulate, that is s plus zeta omega n plus zeta omega n. I'm just splitting that, plus zeta omega n square plus omega d square. So this can be further written as 1 by s minus s plus zeta omega n divided by s plus zeta omega n square plus omega d square. Okay, then for the next minus term is coming inside. For this term minus zeta omega n s plus zeta omega n square plus omega d square. Now we can compare with those two Laplace transform equations, taking inverse Laplace. Taking inverse Laplace. Inverse Laplace. The C of s will become C of t. 1 by s is u of t. This is s plus a. Instead of a we have zeta omega n, so minus zeta omega n t cos omega dt. Cos omega dt. Omega dt minus e power minus zeta omega n t sin omega dt. This is the Laplace transform. Okay, for this the Laplace transform is this. For this is the Laplace transform. For 1 by s the Laplace transform is u of t. Right, now okay, now yes, here it's just a small manipulation. Please note down here it's omega d is here. Omega d. The numerator, look at this term. This term we have the numerator as here it is omega d. So here it should be omega d. Okay. For that, what we are going to do is just please ignore this. Okay, we have still a few more steps to go. Right. So it is 1 by s minus s minus s plus zeta omega n s plus zeta omega n square plus omega d square minus. So in the numerator it should be an omega d term. Okay, so you add you bring a term omega d in the numerator, divide it by omega d minus. Okay, we have zeta omega n, bring omega d, divide by omega d. Right, so s plus zeta omega n square plus omega d square. Okay, so it is 1 by s minus s plus zeta omega n s plus zeta omega n square plus omega d square minus zeta omega n by omega d. This is a, and for this entire term it is omega d by s square plus zeta omega n square plus omega d square. Now you take inverse Laplace. Inverse Laplace transform. Okay, so you get C of t as 1 by s is u of t minus s plus zeta omega n, that is s plus a format, so e power minus zeta omega n t, okay, cos omega dt minus zeta omega n by omega d. This is for the third term, it is e power minus zeta omega n t sin omega dt. Okay, so this is the response. Now a few more steps, right? For our convenience we can still write this as, right, it is u of t e power minus zeta omega n t cos omega dt minus zeta omega n. This is omega n square root of 1 minus zeta square e minus zeta omega n t sin omega dt. Okay, what about we know from the basic trigonometry, okay, 1 second. u of t is, of course, for the positive time, u of t is going to be 1, right? So I can rewrite this as 1 minus omega n square root of 1 minus zeta square e power minus zeta omega nt cos omega dt plus zeta omega n e to the power minus zeta omega nt sin omega dt, right, whole divided by omega n square root of 1 minus zeta square. So you can take e power minus zeta omega nt divided by omega n square root of 1 minus zeta square outside. What you have? You have omega n. Yeah, when you can take omega n outside, right? The omega n will get cancelled, so we can remove that. Okay, you can clearly see this omega n gets cancelled. Taking commonly out, it gets cancelled. So we have square root of 1 minus zeta square cos omega dt plus zeta sin omega dt. Okay, from the trigonometry we will be knowing these things. If this is zeta, this is 1 minus zeta square, this is theta, the hypotenuse is going to be 1. Okay, what is sin theta? From this we can clearly see the sin theta is going to be opposite side. Opposite to theta is, this is opposite, this is adjacent, this is hypotenuse. Opposite by hypotenuse, so square root of 1 minus zeta square. What is cos theta? Adjacent by hypotenuse. What is tan theta? Opposite side by adjacent side. Square root of 1 minus zeta square by zeta. So using this I can 1 minus e to the power minus zeta omega nt divided by square root of 1 minus zeta square. Square root of 1 minus zeta square is sin theta cos omega dt. Zeta is cos theta sin omega dt. Okay, so this is sin a plus b formula. So I can write this as 1 minus e power minus zeta omega nt divided by square root of 1 minus zeta square. This is sin a plus b. So it is sin omega dt plus theta. So this is the unit step response. This is the unit step response of second order underdamped system. Okay, right, and please remember the theta is from this expression, from these three expressions you can write what is theta. Theta you can either go for sin inverse of square root of 1 minus zeta square, or else you can say cos inverse of zeta, or else you can say tan inverse of square root of 1 minus zeta square by zeta. Okay, right, now we will see the graphical representation of this. Right, now the input is unit step. This is r of t, time domain representation. R of t, input is unit step. For this the output c of t, you can clearly see we have the two things. One is the exponentially decreasing. Another we have the sine term which oscillates. It is both are multiplied. So when the time increases, this entire thing is gone. Then ultimately it settles at 1, right? So the response would be So this is the response. This is the input. Okay, right. I hope you learned something useful from this lecture. Thanks for listening. The next video we will be discussing about this for the second order system. For this output, we'll be finding out we'll be analyzing what is the rise time, what is the peak time. This is the peak time. This is the peak time. Okay, this is the rise time. Rise time, and this is the peak overshoot. This is the peak overshoot, and this is the settling time. Those things we'll be deriving in the next video. Again, thanks for listening. Have a nice day.